Hi everybody, today we are going to start section 8.3, and in this section we are going to graph f of x equals ax squared plus bx plus c. So now what's new in this section is now we have this bx term in the middle. This form of our quadratic function, this is called standard form of a quadratic function, ax squared plus bx plus c. What happens when we add in this bx is that the vertex of our parabola is going to move left and right. So not only will it move up and down, but it'll move left and right. And then the a is still causing, it could be a reflection or not, and then it could be a stretch or a shrink. So there's lots of transformations that are going to happen with this. The biggest thing that we need to make sure that we talk about is the vertex, the location of it. So let's go through this here. When we're graphing this function, the graph will open up when our a is greater than 0 or if the a is positive, and the graph opens down if our a is less than 0 or if the a is negative because it causes it to be a reflection. The y-intercept is always going to be the c, the number at the end of the equation. Remember that the y-intercept is when x equals 0. Imagine I were to plug in 0 into this equation for x. If I plugged in 0 here, this whole term would eliminate. And if I plugged in 0 here, this whole term would eliminate as well. The only thing I would be left with is c. So the y-intercept is always going to be the number or the constant added at the end. Now this is important, the x-coordinate of the vertex. To find the x-coordinate of the vertex, we're going to use this formula. This formula to find that x-coordinate is the opposite of b over 2a. So the b and the a come from our equation. The b is the coefficient in front of the x term, and the a is the coefficient in front of the x squared term. So we're going to take those numbers and plug them into this formula, and that's going to give us the x-coordinate of the vertex. If I want to find the y-coordinate of the vertex, all I have to do is take my answer from here, the x, plug it into both of these x's, and find out what it equals, and that would be the y-coordinate of the vertex. Similarly, the axis of symmetry. Remember that the axis of symmetry is this vertical line that passes through the vertex. Well, since it passes through the vertex, that means that the x-coordinate of the vertex is the same as the axis of symmetry. Look at how they cross the x-axis right here. They both have the same x. So if I wanted to find the axis of symmetry, I would again use this formula, the opposite of b over 2a, and make it equal to x because it's an equation of a line, a vertical line.